Alright then, hello guys. Today we're going to be doing a new Hacked Box challenge. The Hacked Box challenge that we're going to be doing today is going to be called Back Computer, which is a phone challenge released almost 3 years ago. So let's get started. So the first thing we do is just check the file permissions, or the file security permissions that it has initially placed. So how I do it, and people do it differently, is I just use a Python script, and my Python script is basically solve to.py, which is just from pwn import all and then elf it and then the name of the file. That's basically all I do. And the first thing that app pops out is NX disabled. So that means shell code is allowed. We're allowed to execute shell code, so that makes it easier. And then no canaries found. So these are the two things that popped out straight to me. So that means we could execute shell code in the stack, or in the I guess in this program. So first thing I did was just try what the program does, back computer. And we see here we can have two options: either one, track computer, two, chase joker. So first thing I did was just press one, see what happens. One, all it does is just print out the address of something randomly. So we'll figure it out later on in the video. And then with number two, looks like, let's do this. It asks us to enter a password, and then after input a password, but we don't know the password currently. I tried putting like password or something, and then it's wrong. I kind of give you access to Batmobile, so we don't know what this is asking for. So I hopped it on something that we could decompile it. Like in my case, I used IDA, but you could use probably like Ghidra or something to decompile the code. And I went on to IDA, and then we see the same patterns. Welcome to your back computer. What would you like to do? And then after that, it asks us to input a number. If it doesn't equal that number, all it does is just a simple break, and then break. And then it looks like yeah, it just does simple breaks. So if you don't input the number 1 or 2, it just breaks out of the code. So, what did I press? I double press something. Just click main. Pseudocode? Yeah, pseudocode. Anyway, yeah. So it looks like it just breaks, and then after that, yeah, it just does breaks. So, anyway, let's see. If you enter 2, okay, let's do the enter the password, and then the password seems to be hard coded with bat password. So if we try this again, back computer. Oh, and also, I guess to mention the 1. If you press 1, it seems to be printing out the address of v6, which seems to be an array holding an array holding 76 bytes. And then later on, if we check right here, if we press 2, let's enter the password. I'm gonna enter this password. Oh my god, my hands aren't that steady. And I got it. So I'm gonna enter the password right now. And it asks us to enter navigation commands, and those navigation commands are being inserted in v6. Now, I'm not sure if you guys noticed this, but the main vulnerability with this is that we're inserting 137 characters. Oh, I double press it again, but where's main? Where's main? Where's main? Where's main? Oh my god, I'm blind. Oh my god, pseudocoding. Anyway, if you see here, we're entering 137 characters to v6, which can only hold 76. So I'm guessing that's where the vulnerability happens. So my guess is what we're supposed to do, or like what I know what we're supposed to do, is we're supposed to input a huge buffer. After that, we have control. We need to find out where EIP is, like in our last video that I did with Hackbox. And after that, we put the address of whatever we want. In our case, we're given an address which seems to be the v6 array. We input the v6 array, and what this is gonna happen is that this is gonna, once EIP points to this specific address, it's gonna point to the beginning of the array. So our A is technically gonna be is we're gonna fill this up with shell code, and then after that, shell code until we reach EIP. And EIP is gonna be this address, which is the array address. So what's basically happening is that we input our shell code, and once we find the offset, we enter our shell code, and then at EIP, once it reaches this address, it's gonna go to the beginning of where this array is stored. And our array is stored in navigation command, and whatever is input in our navigation command is v6. It's gonna point to the beginning of v6, and it's gonna run our shell code from the beginning. So it's gonna run all this that we input at the beginning. That's basically the gist of the challenge. So right now, what we're supposed to do is find the offset of our shell code. So what I'm gonna do is basically run it through GDB. So GDB back computer. we find the offset. So finding the offset is not that hard. All we need to do is just create a pattern. So I'll just create a pattern, create, and then the pattern we could put it like a big old size, but the size I'm gonna go with is 137 because that's how much we could input inside our V6, even though it's only 76 bytes. So I just do pattern create 137, and it creates a pattern for us like we did before. And now what I'm gonna do next is just press run. It's gonna ask us to enter something, so I'll press 2. We're gonna enter the password of the rest of the program. So I'll just enter bat, copy, bat, access granted. Now we need to enter navigations command, which I'm gonna copy all of this and then put it inside here, and then press enter. And now we're back here again. So what we want to do now is be able to exit. We want to be able to exit out this code, and then we'll see if it affected it or not. So how to exit, we just need to put a number that's not 1 or 2 so you could successfully put exit or just exit out the program. So I'll just do 3, and then boom, we exited. And you see right here that we got back computer stopped at this specific value. It seems like it overwrote this value. And if we look closely right here, looks like it got messed up. So what we could do now is basically find the offset like how we did in our previous video. So what we could do is just look up pattern offset, then RSP, pattern offset RSP, and then we find out that the pattern is at 84. So that's where this is where our offset is, so we could reach the point where the code faulty. So that's gonna be, we're gonna fill it up with 84 bytes of shellcode. That's basically what we're gonna do. So now what we're gonna do is construct our shellcode, which is pretty easy, which you could do easily with Pwn Tool. So what I did was just I already have my solve script ready here. So what I did was just do context binary, which gets all the context, sets up the context for the back computer. I ran ELF, and we have process right here. So we first need to get the address of the array. So this is what I have right here. So I press 1. And then we receive until we get this message, and after that we have the array right here. And I'll just print this out right here. Print command address. I'll have this out right here so you guys can see it. And then I'll just comment all of this out. Comment this out, comment this out, comment this out, comment this out, comment this out. Just comment this out, and then I'll just uncomment it one by one until we Python 3 solve.py. Solve.py. So we see here, I guess I misspelled something. Command ADR Python 3, and then see, look, it prints out the address of that we're trying to receive. So this gets the address of the array. So now that holds the address of our array. So now what we're gonna do next right here is we print out the offset. The offset that we got from GDB was 84. Okay. Now initially, how some people solved it is they created their own shellcode, but you don't need to do that. You could use a special feature in which you create a shellcode by using the Pwn Tools feature, which is shellcraft.sh. And from here, our payload starts off with shellcode, like how I explained at the beginning. So it's gonna be our let's put a comment right here, our shellcode plus EIP, which is gonna equal the address of array. So now we have our shellcode right here. Then we pass it around to ASM. This turns it to bytes. So we set this off. Now you see here, this is a little bit of math that we have to do. So we know the offset is 84, right? That's how much we have until we reach the end. So what we're gonna do is subtract the offset minus the length of our payload. So it's gonna make a, let's say it's 84 A's to reach EIP. But then we want to fill the beginning part with our shellcode. So let's say our shellcode is like 20 bytes long. So 20 bytes is our shellcode. Then plus 64 is going to be A or NOPs, not values, just to fill it up. And then after that, we could put our address. That's basically what's that's setting up right here on these three lines right here. So it's gonna be our shellcode, or our n amount of bytes for shellcode. So I'll just put this as n plus whatever 84 minus n is, and then our address. That's basically what this is doing. And then after that, right here, I just print out the length of it and print out the offset of it so we could view it on real time. So I'll just do that, and after that we do number 2 to send the line number 2. And then right here we just send in our password that was from right here, that password. Then after that, it's gonna ask us to input stuff into our v6 array, and our v6 array is gonna hold our payload. That's basically what happens. And then after that, we want to send 3 so it could exit out the program, and we receive a few lines after, and then we have interactive mode on. So interactive will like activate our reverse shell. So now if we run this, we see that we get a little bit of errors right here. Python nano shellcode. Oh yeah, okay. So like, let's just assume this plus wasn't there. So we try this. If we try this, we see it's starting the process, doing everything correctly. Like I had trouble with this because I kept getting the end of file while reading an interactive. So this was the error like I saw a lot of people get. And how most people solve the challenge is they basically solve.py is they basically they just created their own shellcode by using, like I said, MSF Venom. But I didn't want to do that in case I want to be able to use the shellcraft.sh. So I saw the CryptoCats video, and he was saying like the shellcode, basically the shellcode was like the one that Pontos was using was so big that it kept messing up the shellcode around it. And a way around it on how to fix that, you basically just need to add a pop pad, which is gonna like just fix the shellcode for the most part. So if you add the shellcode ASM shellcraft pop pad at the beginning, and then after that you do the plus equals, that's gonna be able to solve the challenge. So if you do Python 3, that'll solve, and it's waiting for this to load up. We wait, and then boom, we get interaction. So if I type who am I, it's gonna say root, which is my computer. Now what we could do now is just basically connect to it remotely. So if I type exit, go to solve.py, and then for right here, I'll comment this out and do p equals remote, and then just pop this out right here, comma, that, and then if we try this, our thing should work now. So we get this. We should wait, and then boom, we have interactive mode. So if I type ls, we see the file, the executable file, and we see flag.txt. So we cat flag.txt. We should get the flag, which is hack the box, love yourself, you saved the world. So I'll just copy this and then just submit the flag. And then submit the flag. That was about it for this challenge. This was easy challenge for the most part, like still getting introduced with a shellcode, and just showing you guys that in some challenges sometimes you have to create your shellcode, like I did in the previous video, but sometimes it's just as easy as using the basic ones that Pwn Tools provide, which is shellcraft.sh. Sometimes it will work just like this itself, or sometimes you might need to add a pop pad feature. It just depends. You might need to run it through a debugger and see how it goes on live, and like go through it bit by bit to see what's happening wrong with your shellcode. But yeah, that was about it for this challenge. I hope you guys learned something new today. I know I did. Yeah, that was about it. Hope you guys enjoyed, and peace.